Hello everybody, in this question we need to show that 1n cubed plus 2n plus 3n square is divisible by 2 and 3 for all positive integers n. So we can rewrite this question as, show that n cubed plus 2n plus 3n square is divisible by 6 for all positive integers n, because if it is divisible by 2 and 3 then it must be divisible by 6, or vice versa. If it's divisible by 6 is divisible by 2 and 3. So by 6 for all positive integers n, right? So we use proof by induction. That's why I've written there, proof by induction. So that will help us prove this. So I will say use proof by induction. So so I'll use this method, use proof by induction, to get the result. So when we do proof by induction, we will say that suppose the statement n square plus 2n plus 3n square is divisible by 6 holds true for n equals 1. So we can see that 1 plus 2 plus 3 equals 6, which is divisible by 6. Suppose it is true for n equals 2. So we'll get 8 plus 2 times. So maybe we could write it, explain it a bit more. So then 2 cube plus 2 times 2 plus 3 times 2 square. That's 8 plus 4 plus 12. And that is equal to 24, is divisible by 6. So let us now assume that the statement holds true for n equals k. So suppose the statement is true for n equals k. So if that is the case, then you can say k cubed plus 2k plus 3k square is divisible by 6. Hence we can write, so k cubed plus 2k plus 3k square is equal to 6 times, any integer you can say. Suppose I say 6y, where y is any integer. So because a multiple of 6, okay, so we can say this. So to prove that the statement is true for n equals k plus 1. Okay, so n equals k plus 1. So then what happens when n equals k plus 1? When n equals k plus 1, we can write when n equals k plus 1, then we can write k plus 1 cube plus 2 times k plus 1 plus 3 times k plus 1 whole square. We need to prove that this is divisible by 6. So that is equal to k cube, expanding the bracket, plus 3k square plus 3k plus 3, sorry, plus 1, not 3. Sorry about that, plus 1, and plus 2k plus 2, and plus 3, expanding the bracket, you get 3k square plus 2k, so 2 times 3 is 6k plus 3. And that is equal to k cube plus k square, so plus 6k square plus 3, 2, 5, and 6 is 11k, and plus 3 plus 3, 6. Now we can break up this expression to something in this format. So then I can write that is equal to k cube plus 2k plus 3k square. Okay, and plus the remaining k cubes gone, we have 2k, so 2, and here there is 2 plus 9, 11, so 9k plus 3k square plus 6. Now that is equal to, I can write 6y plus 9k plus 3k square plus 6, so that is 3. If I take outside the bracket, I would get 3. So I want to write the k square term first. So I will write k square plus 3k plus 2. See, I can factorize that. So that is equal to 6y plus 3 times k square plus 2k plus k plus 2. And that is 6y plus. So this thing becomes k, if you take outside the bracket, k times k plus 2 plus 1 times k plus 2. That is k plus 1 times k plus 2. So I can write 6y plus 3 times k plus 1 times k plus 2. Now you see this k plus 1 and k plus 2 are consecutive integers. Consecutive numbers, so they are, so must be a multiple of 2 and must be a multiple of 2 because these are consecutive integers. So 1, it is a multiple of 3 and it is a multiple of 2. So we can write this as hence k plus 1 times k plus 2 can be written as 2, suppose p. Where p is any integer, right? Where p is any integer, so hence we can write this expression. So this becomes 6y plus 3 times twice of p. So which is a multiple of 6? So if this is a multiple of 6, hence the statement holds true for n equals k plus 1. So where are we? N equals k plus 1, right? So the statement holds true for n equals k plus 1. Hence, it holds true for all n equals k. For all. So our question is for all positive integers n. So all positive integers n. So then to sum it all up, so we can say that n square plus 2n plus 3n square is divisible by 6 for all positive integers, and therefore you can say that 1n cubed plus 2n plus 3n square is divisible by 2 and 3 for all positive integers n. And that's it. That concludes the proof.